To understand the next part, we need to look at these numbers here and see what we can do by calculating the z-scores. Okay, so let's look at this one here. That's the mean, right? So let's find the z-score for that one. You remember the z-score? So the z-score is x minus x bar divided by standard deviation. But now it's going to be, for population, z-score is going to be x minus mu divided by sigma. Same thing, just different terminology because we're talking population. So we're going to find the value of 6.84. So your x is 6.84 and your mu is 6.84 in this case. So 6.84 minus 6.84 divided by the standard deviation, which is 1.55 if I'm not mistaken. Yep. That's 0. So right here in the center where the mean is, it's 0. Okay, let's find the other one here, 8.39. Okay, so 8.39 minus 6.84 divided by 1.55, and you're going to get 1. Similarly, if I find it for this one, 5.29 minus 6.84 divided by 1.55, I'm going to get -1. Okay, what we're doing here is we're standardizing this, finding z-scores for these values instead. And what it gives us is this normal curve. It's the standard normal curve. Where the, I don't know, this bothers me if it doesn't appear in the middle. The center is where the mean is, and it's 0. 1 standard deviation away is 1 here, 2 standard deviations away. Z-scores are standard deviations, remember. So, okay, all of these are z-scores, and they're standard deviations. Oops. I always write stand devs for short. Okay, so center, the mean is 0 standard deviations away from the mean. Exactly on top of it, right? Okay, makes sense. 1 standard deviation to the right, 2 standard deviations to the right of the mean, and 3 standard deviations to the right. 1 to the left is -1, 2 to the left, and then 3 to the left. And yes, all right? Okay, so why do we care to know this? Well, the area under the curve tells us something important. And so we need to know this area here. A lot of times we need to know the area right here, or the area right here, or the area in between here somewhere. Okay? Just like we were using the 68, 95, 99.7 rule to find areas. That's great if you are talking about stuff you want to find exactly, like between the standard deviations. What if I wanted to know the percentage from like here on to the left? There's no way to calculate this using the method here. No way to do it. Okay? So to be able to find that, we first need to understand the standard normal curve, and the area underneath, and the relationship between the z's, and this is on the table. The table I gave you has z-scores on the margins. So if we're looking at 0.81, that's the z-score, let's say. This is a z-score of 0.81. What's the area? What is the area up? Area up to that z-score. So let's think here. This is in the center, 0. 0.81 is kind of here somewhere, 0.81. Not quite 1 standard deviation away. It's an arbitrary 0.81 standard deviations away. It's not an exact 1. Like, it's not perfect like this, 1 standard deviation away, okay? So it's 0.81 standard deviations away. How do I find it? I look at the z-score table. I find where it's 0.8 on this side, and then the 0.01 comes from the top, and it's where you meet. As you can see, you're going to go down here, right there. You're going to go over this way, right there. This is the area that is right here. This area here, right here, is 0.7910. Okay, and so this represents a percentage. So it's going to be 79.10% when we talk about like in context of a story. Okay, and so let's look at first practicing using this to find specific standard deviations. So right here, I'm going to do A. All right, and less than 0.81. I think we already did this. Oh well. So 0, 0.81. We use the table. And so less than is this area here. And then we use the table. And we find that this area is what did we say it was? 0.7910. Yep. So what proportion? This is a percentage. You could leave it as a decimal or a percentage. It's just going to depend on the question. You could also say 79.10%. All right, we're going to say greater. We're going to find greater than negative 1.78. So you're going to draw your standard curve. And the middle is 0. Negative 1.78. Somewhere here is negative 1.78. Greater, you're going to shade the greater area, which is here. Okay, we're looking for the greater. All right, so then you find the z-score on the table, and you find the area associated with it, and it is, let me look at my paper here, 0.0375. But guess what? That area is here. And we don't want that. This is this. How do I know that? Well, the table always gives you from the left side, this side. It always gives you the less than. So to find the greater than, you're going to subtract that from 1. 1 minus 0.0375, and that comes out to be 0.9625. All right, so the correct answer for this one would be 0.9625 here, or 96.25%. They're interchangeable. Okay, and the last question is asking between negative 1.25 and 0.92. So draw your normal curve as best as you can. This is a 0 in the middle. I'm doing a very crappy job right here. If I take more time, I do better. This is negative 1.25 about. This is 0.92 about. Oops. So it's looking for in between. All right, so we're going to find the area up to the negative 1.25, and we're going to find the area up to the 0.92, and then we're going to subtract them to find this area. So if you want, you can find the bigger area first. So the bigger area is up to 0.92. Up to 0.92, it is 0.8212. That's associated with that z-score. And then this z-score is 0.1056. I did this on purpose in this order because I'm going to subtract, and the smaller one should be subtracted from the larger one so we don't get a negative number because area can't be negative. And so 0.7156. And so therefore 71.56 if you wish to convert that to a percentage. 0.7156 is the area. Okay, so if it's less than, you just find the z-score, you just find the area and you're done from the table. If it's greater than, you find the area up to that point, the z-score, and then subtract it from 1 if it's greater than. If it's in between, you're going to find both areas and you're going to subtract the smaller one from the larger one, and you get your difference and find the area. Okay, so we're going to go backwards now. And what are we doing that? To do that, first we're going to, of course, draw our normal curve. So working backwards from areas to z-scores, find the specific percentile of the normal standard curve here. Okay, so 90th percentile means the area underneath the curve is 0.9. So the shaded area is this, that 0.9. So 90% of the area is shaded. Okay, and so if that area is 0.9, what's the z-score here? That's what it's asking for A. And so how do I find that? I go back to the table. This table, I need to find the z-score, the area that's 0.9, closest to 0.9. All right, and the area closest to 0.9 is for z-score 1.28. Show you how I found that. Okay, so z-score 1.28. So I'm looking, and I see the numbers are getting close here, and this 0.8997 is closer than 0.9015 if you really have to subtract. So 0.9015 minus 0.9, it's 0.0015, and then or if you subtract this, this is only 0.0003 away. So this is closer. So it's 1, so like right here, first I identify which one is this one's the closest to 0.9. Then I look up and I look to the margins and it tells me it's 1.28. And that's how you get the z-score of 1.28. All right, let's do the 27th percentile. The 27th percentile is that, where it's 0.27 area here. And what's the z-score here? Well, you're looking for area 0.27. So you're going to go back to the table. It's not going to be on here because it's smaller than this number, but if you go back to the first page and you find that the area closest to the 0.27 is for z-score 0.61, negative 0.61. And then similarly for C, it's the 50th percentile. So it's 0.5 right in here. That should be easy. If it's the halfway mark, what's the z-score at the halfway mark? You don't even need to look at the table for that. The 50th percentile is 0 for z-score.